giving us a new set of eyes to explore outer space. Over a 2-year mission, it will use its unique X-ray vision to study some of the most mysterious and powerful objects in our universe. Thank you for joining us this morning, live from Kennedy Space Center in Florida. I'm Megan Cruz.
And I'm Marie Lewis. Liftoff is set for 1 o'clock a.m. sharp Eastern Time from just behind us at historic Launch Complex 39A. IXPE is NASA's first mission to study polarized X-rays. Simply put, it will help us understand how the universe works. The mission will focus on objects like black holes and exploded stars, honing in on their cosmic X-rays. These rays originate from places where matter is under extreme conditions, violent collisions, enormous explosions, 10 million degree temperatures, and fast rotations.
And IXPE is unique because it will pinpoint X-ray polarization. Soon after launching, IXPE will deploy its solar arrays, which will power the spacecraft. After about a week in space, IXPE will extend its boom, lengthening the spacecraft to about the size of a minivan. There that boom goes. About a month after launch, IXPE will begin its 2-year mission using 3 identical telescopes, each with a set of mirrors. Those mirrors have corresponding detectors on the opposite end of the boom. The mirrors collect X-rays from the celestial objects and focus them on the detectors, which make an image of those X-rays and measure polarization.
Polarization is a property of light, like brightness and color. X-rays are a form of high-energy light that's invisible to the human eye. By studying the polarized X-rays of these powerful objects, we can learn more about what they're made of and how they work. Today's launch is managed by NASA's Launch Services Program in cooperation with the agency's Marshall Space Flight Center, the Italian Space Agency, and Ball Aerospace.
And here are some other interesting facts about IXPE by the numbers. The bottom of the observatory, called the spacecraft bus, is nearly 4 feet in diameter. Up top is the mirror module support structure deck that's almost 5 feet in diameter. The boom is 12 feet long, bringing the fully extended observatory height to 17 feet.
IXPE's solar array wingspan is 8 feet. Put it all together, and IXPE weighs 727 pounds, roughly the same as a polar bear. It will study about 40 celestial objects during its first year in space, with more detailed follow-up observations in its second year.
And IXPE arrived at Cape Canaveral Space Force Station on November 5th for final pre-launch testing. Teams attached it to the Falcon 9 rocket last week, and now here we are, stacked and vertical on the pad, ready for launch in just about 26 minutes. Throughout this broadcast, we will show you exactly how polarization works and why measuring it will be a game changer for astrophysics.
That's right, and we will also introduce you to some of the key people who made this mission possible. NASA's Jasmine Hopkins will be interviewing those guests live, but first, let's bring in our launch commentators for today's mission. NASA's Daryl Nail and Mick Woltman sitting inside with the launch team. Daryl and Mick, how's it going?
Well, it's going great, Megan and Marie, and welcome inside the Mission Director Center here at Hangar AE with Mick Woltman, engineer extraordinaire for Launch Services Program, going to be giving us his expertise tonight. We've had a very clean countdown so far, which is great. The launch vehicle is healthy. The spacecraft is healthy. The range is clear. And the weather is only getting better, looking fantastic. Look outside at the rocket, and you can see it is a beautiful shot, starting to fuel. Mick, just a few minutes ago, we had a poll that kicked everything into motion.
Yeah, NASA's launch manager, Tim Dunn, polled the NASA engineering team, the spacecraft team, to verify they were good to start propellant loading and get ready for launch this morning, and that was great. Tim said that everything looks favorable, and we are go for propellant loading and go for launch.
And once that propellant load started, and it continues to start now, and it continues to go on as we speak, that also eliminated something that was true about an hour ago, but is no longer true, and that is we had a 90-minute window. It's no longer the case.
That's true, Daryl. Once we started propellant loading, we committed to a specific time in that window, and that is 1 a.m. this morning for IXPE's liftoff. And that's or super chilled locks on board the Falcon 9 at minus 340 degrees. We need to keep it at that temperature because it warms up pretty fast. And if we can't do that, then we miss our opportunity. So we have committed to this, and we're heading for a T0 at 1 a.m.
And you can see that lock starting to fill because it's chilling the bottom part of the rocket where it is condensing and making that white cloud that you see there. This rocket has an interesting ground track in order to get this satellite into orbit. Let's take a look at that now. Once it launches here from the Cape at Kennedy Space Center, you see that red line. That's the powered flight. Then it goes into a coast over the Atlantic Ocean. Well, what's interesting is what happens next. After it passes over West Africa, it gets close to the equator, it does this. Bang! A 28-degree turn. Why is that?
Yeah, so that last burn of the second stage gives us that 28-degree plane change, which puts IXPE into an equatorial orbit, which is very important for the science mission. And Daryl, we'll talk about that later.
We're going to talk about that, as well as this historic pad right here, Launch Pad 39A, with the first ever dedicated science mission launching from here. We'll also talk about the history of that booster. But for now, back to Megan and Marie.
All right, thanks, Daryl and Mick. We want to bring in now NASA's Jasmine Hopkins, who is at a nearby viewing location.
Yeah, she's there with the director of NASA's Marshall Space Flight Center in Alabama, which is the lead center for the mission. Right, Jasmine?
That is correct, Megan. And we're going to have a great view of launch from right here at the balcony of the Operations and Support Building at Kennedy. And I am so glad to welcome Jody Singer. Thank you so much for being here.
Well, thank you so much for having me.
Absolutely.
This is a fantastic time, an exciting moment.
It is. We're very excited. And Jody, tell me, Marshall has been at the heart of the IXPE mission. How are you feeling to be here for launch?
Well, it's one of those things that, you see all the excitement, you see the sacrifices, you see how much energy our team, and it's our team, it's Marshall, but it's, the Italian Space Agency and Ball Aerospace, as well as many other folks. But our Marshall team is extremely excited about the science that we're going to get out of it, the new discoveries, and, we haven't done this before, so we'll not know what we'll find till we actually get it in operation. But it's just really exciting time and a lot of pride.
It is. And we're very excited with you. We're all going to discover these things together. But can you tell me, what has Marshall been doing to prepare for the IXPE mission, and what will operations look like over the next few years?
Well, definitely, I'll tell you, there's been a lot of hard work, for sure. But a lot of our scientists, engineers, working with our partners, but definitely working hard. Particularly Marshall Space Flight Center is responsible for the mirrors. There's over 72 mirrors on it, and those mirrors are very critical to be able to see the light that is coming from the different objects that we'll be pointing at, and then sending it down to the detector and being able then to understand what we're seeing. And so it's just unimaginable, a lot of the things, from deep stars to a lot of the energy, seeing we don't even know what we'll be seeing. So that's going to be fantastic, and that'll be a lot of hard work. When the IXPE is commissioned in about a month, it will, it has to go through its different stages and check out to be operational in space. But once it's there, it'll be a 2-year mission. There's going to be a lot of the things that we'll be looking at, neutron stars, understanding how planets were formed, understanding all about things that we don't even imagine yet that we're going to see, because we've never seen it before.
Exactly.
We've estimated what it would be like, but getting to see it. And then there'll be continuous research that'll be done. And it's over 12 countries and over 120 more scientists from all across the world that'll be getting this information. And that's something that's great for the United States, but it's also great for partnerships. We go together, learning about our universe and understanding our world.
Right. We go together. I love that statement. And, the Marshall team has been working behind the scenes on this to uncover the mysteries of the universe. So what do you want the world to know about your team at Marshall?
Well, I think they're pretty special. It's a great team of scientists and engineers working hard, dedicated, and, really just giving it their all and really excited about the unknown possibilities, understanding our world. In addition to that, Marshall Space Flight Center, lifting off from the surface of the Earth, traveling to and through, living and understanding in our world, and now the unknown mysteries of our universe. So, it's just going to be a lot of fun. It's so bright, the future.
Yeah.
And, and it's not just about us. It's about the next generation understanding our world and where we're going. So the future is so bright.
Yes, it is. Jody, thank you so much for being here. And now we're going to get a forecast from our launch weather officer, Will Ulrich of the Space Launch Delta 45. Over to you, Will.
Thanks, Jasmine. Conditions look excellent for an early morning launch this morning, despite the fact that we have some clouds moving overhead the state. And that's thanks in part to a weak cool front that we're slowly seeing sag south over the area. A live look at satellite imagery shows those clouds moving from the eastern Gulf of Mexico and into the western Atlantic Ocean. Now, my colleagues at the 45th Weather Squadron are actively evaluating 9 lightning launch commit criteria to ensure those clouds pose no threat of both natural and rocket-triggered lightning. And the good news is that since we started evaluating the weather at L-2 hours, conditions look very favorable. Now, Mike McAleen, the launch weather officer for this mission, just gave his final weather brief at L-1 hours and gave a greater than 90% go for weather. And the good news is that should we need to utilize tomorrow's backup window, weather conditions remain the same with an 80% go for weather. Marie and Megan, back to you.
All right, thank you, Will. Great to hear. Fantastic news about the weather. It is currently T-minus 18 minutes from liftoff.
Yeah, previous NASA missions have studied cosmic X-rays before, but never the way that IXPE will. It's a new set of eyes in space that could unlock secrets of our universe.
To answer some of the biggest questions about what's out there in the universe and what it all means, we need powerful telescopes. NASA unravels the mysteries of the cosmos using observatories in space that study the different wavelengths and properties of light. The Imaging X-ray Polarimetry Explorer, or IXPE, will study X-rays from some of the most extreme objects in the universe, like black holes, in a new way. IXPE will look at a special property of X-rays that has gone mostly unexplored until now. It's called polarization. X-rays come from the hottest places in the universe. Imagine powerful explosions, violent collisions, and strong magnetic fields creating chaos in the darkness of deep space. X-ray telescopes can trace clouds of gas heated to millions of degrees and detect the shower of particles fueled by a feeding black hole. Building on the discoveries of NASA's Chandra X-ray Observatory and other space telescopes, IXPE measures the orientation of X-rays from some of the most brilliant and bizarre objects in space. Like all forms of light, X-rays consist of moving electric and magnetic waves. Usually, the peaks and valleys of these waves move in random directions. Polarized light is more organized, with the two types of waves vibrating in the same direction. You might have heard of polarized sunglasses. Boaters and fishermen use these lenses to reduce glare from sunlight across a body of water. Water reflects light in a way that causes some of it to vibrate in a direction parallel to the water's surface. Polarized lenses block light moving horizontally, but let other light through. Much like the way light changes when it bounces off of water, in space, light becomes polarized depending on where it comes from and what it passes through. By measuring the amount and direction of polarization, IXPE gives us clues about the shapes, structures, and inner workings of all types of objects that shine in bright X-rays. The IXPE Observatory has 3 identical telescopes with 3 main parts: mirrors, detectors, and an extendable mast, or boom, that separates them. Each mirror assembly contains 24 nested mirrors that collect and focus X-rays. Located at the focal point of the mirrors, sensitive detectors made with international partners in Italy are the secret behind IXPE's unique X-ray vision. They track and measure all 4 properties of incoming light: its arrival time, direction, energy, and most importantly, polarization. Over the 2 years of its prime mission, IXPE will observe more than 50 brilliant objects, like the leftovers of huge stars that exploded into supernovae. the supermassive black hole at the heart of our own Milky Way galaxy, and pulsars, the dense remains of stars that once were. These observations will help scientists tackle long-standing puzzles, like testing competing theories about pulsars and the details of how Einstein's theory of general relativity works. New insights from IXPE will help us paint a fuller picture of the universe, confirming or confounding our thinking in the years to come.
Really such a fascinating mission. I can't wait to see what they uncover. And as you heard in that video, the Italian Space Agency built an important part of IXPE. Let's get back over to Jasmine, who's with the agency's president. Jasmine.
Thanks, Megan. Yes, now I am joined by Giorgio Sococcia, president of the Italian Space Agency. Thanks so much for being here.
Thanks to you.
Yeah, absolutely. So there's a lot of science that is going into the IXPE mission. Can you tell me, what is the Italian Space Agency's biggest contribution to IXPE?
Well, we have provided detectors, which are quite an innovative development, and some other elements of the payload unit. We also provide the main tracking station. Is a site we have in Africa, in Kenya, and some other elements also.
Okay, great. That's really fascinating, very exciting. So can you also tell me about the partnership between the Italian Space Agency and NASA? What makes that so important?
We're talking here about something which is really historical for us. It goes back to the very beginning of Italian space history. Our first launch in '64, our first satellite was launched thanks to a collaboration with NASA, and this has developed over the years on many exciting missions, contribution to the International Space Station that our country gave with a lot of modules, pressurized modules. Of course, we want to now have a big contribution to the Artemis program, which we are already doing through the European Space Agency, and we will do also in direct collaboration with NASA. So it's really, for us, outside Europe, the main partners, and will always be.
Right. And of course, we're always glad to partner with you. Thank you so much for being here, Giorgio Sococcia.
Thanks to you, and let's cross the finger.
Yes, absolutely. Now we're going to look at Andy Tran from SpaceX headquarters in Hawthorne, California. Over to you, Andy.
Today marks the 5th flight of the SpaceX booster we are using to fly IXPE to space, and its 3rd flight on a NASA mission. You can tell by the reentry soot on the bottom of the vehicle that this booster has flown before. Just over a year ago, this 20-story tall Falcon 9 launched Crew Dragon and NASA's 4 Crew 1 astronauts into the night sky and onto the International Space Station for a 6-month mission. The launch was historic because it marked the first operational flight of Crew Dragon. About 9 minutes into flight, the first stage, or the bottom 2/3 of the vehicle, returned from space and landed on our drone ship, Just Read the Instructions, off the Atlantic coast of Florida. 5 months later, the flight-proven booster returned to Pad 39A for another night launch, this time launching the 4 astronauts of Crew 2. The booster returned once again to Earth and landed, this time on our drone ship, Of Course I Still Love You. Those 2 flights, plus a mission for Sirius XM and another for NASA's Cargo Resupply Mission 23, brings us to today, the 5th flight for this first stage booster, carrying IXPE to space. Tonight, the flight-proven booster is back at Pad 39A to launch its very first science mission for NASA, and also marks the 5th NASA science mission overall for SpaceX. For this launch, the booster will send IXPE skyward out over the Atlantic for about 2.5 minutes, and will return back to the drone ship, Just Read the Instructions, about 9.5 minutes after liftoff. And for the drone ships, to give some perspective, they are quite large. Each are the size of a football field. And that does it for us here at SpaceX's headquarters in Hawthorne, California. Now back to you at Kennedy Space Center.
Thanks, Andy. Always great to see you. We are now about 10 minutes from liftoff of a Falcon 9 rocket with NASA's IXPE aboard.
So let's bring back in Jasmine, who is with our NASA administrator. Jasmine?
Thanks so much, Marie. Yes, I'm honored to be joined by our NASA administrator, Bill Nelson. Thank you so much for being here.
Oh, what a pleasure. What a great night.
Yeah.
And it's almost down to the final minutes.
Yes, we're really excited to have you here. And IXPE is an exciting mission. So how is NASA going to benefit from it?
Well, as we try to explore the heavens to understand ultimately who we are, why are we here, how did we get here, we go out and we try to understand things that we don't really understand yet, like black holes. black holes emit X-rays. So this scientific mission is going to go out and capture those X-rays to understand giant holes and neutrons, and when they spin, they become pulsars. And so these are phenomena that emit X-rays, and we can get to other galaxies and see how that X-ray is being emitted and try to understand what this phenomena is.
Right. We're hoping to learn a lot of new information from IXPE. This mission is also a great example of both our commercial and our international partnerships. So can you tell me how our partners help us complete our missions?
Oh, they are absolutely important to us. The International Space Station has some 30 international partners. In this case, the Italian Space Agency is a major partner. It was on our last mission called DART, intercepting an asteroid. We have astronauts that are Italian. There's a German astronaut up there on the space station. The Russians have been our partners since 1975, so our international partners are very important.
Right. A lot of partnerships have gone into this, and we have a lot of exciting missions coming up, and we're really looking forward to completing those with our partners as well. And now we're going to take it back to Megan and Marie.
Thank you, Jasmine. Thanks, Administrator. We now have only about 7 minutes to go before launch, before we see it lift off right here behind us. So let's bring back Daryl and Mick to walk us through the final moments of the countdown. Guys?
Yeah, that's right, Megan. Things really getting exciting here as we count down to the last few minutes before liftoff from historic Launch Complex 39A. The first time for a dedicated science mission as we look up at IXPE contained inside the fairing. And, you know, the booster that's taking it up today, Mick, has some history. And it's really interesting, all the different missions it's flown. It's flown 4 prior missions, and there you see them. Crew 1, Crew 2, Sirius XM-8, and CRS-23, 4 in all, and it's been reused now for today's flight with IXPE.
Yeah, as we heard from Andy Tran earlier, this booster 1061 first stage, this will be the 5th flight for IXPE, and Daryl, as you mentioned, those flights before were historic off of 39A here, 3 of them anyway. And of those 3, Crew 1, 2, and CRS-23 LSP, Launch Services Program, was very happy to partner with the Commercial Crew Program and the Commercial Resupply Program to provide advisory services. So we're very familiar with this booster, very happy to be flying this for IXPE. It's our 2nd time flying a previously flown booster. You and I just got to witness our first time on DART on the West Coast.
Indeed.
But today we're here for IXPE with this booster.
Did you notice something about all those shots and this particular flight tonight?
They're all in the evening.
That's correct.
Or early morning.
This is a night booster.
That's right.
It's a night rider.
Stage 1, RP1 load complete.
All right, there we heard a milestone of RP1 load complete.
Yeah, on Stage 1, we heard earlier Stage 2 was completed, so that rocket propellant 1 is now loaded into the 2nd stage and 1st stage tanks. That's a great thing to hear as the team continues to load that super chilled, densified liquid oxygen into the 1st stage and 2nd stage, and we will continue that for quite a while, right down to the final minutes here, Daryl, as they top off those tanks to get as much propellant in there that they can for the ascent of IXPE on its mission, but also to bring this booster back a 5th time.
That's right. This booster landing on the drone ship Just Read the Instructions, which got out into the middle of the Atlantic Ocean at its holding position at 10 a.m. this morning Eastern Time. We are counting down 5 minutes and 20 seconds until liftoff of IXPE on a Falcon 9 rocket at 1 a.m. Eastern Time here at the Kennedy Space Center. And we're also counting down to another big milestone at 5 minutes when that spacecraft goes on internal power. Let's listen in for that call.
So, Daryl, we just heard the spacecraft SMD over on the NLM net report out to NASA's launch manager, Tim Dunn, that the spacecraft is on internal power. They are ready for launch this morning. That's a big milestone to make sure that IXPE is prepared and ready to get going at 1 a.m. this morning for liftoff.
That's right. We didn't hear it on the public net. That was something that we heard on the communications between the launch teams. Now we're looking for that strong back, the structure that brought the rocket out and put it vertical on the pad from a horizontal position to lean back a little bit. We're also seeing some venting. Look at the top, towards the top of that rocket. You can see some of the pressure from that super cool liquid oxygen starting to boil when it gets into that warm atmosphere of the rocket, and also venting it off, since we're pretty close to fueling this thing all the way.
Yeah, as we get the propellant tanks loaded and we get near the top of those, as you said, that super cooled LOX at minus 340 degrees starts to boil off or warm up very quickly, and we have to relieve some of that pressure from the tanks, and that's what you see, that venting, as you mentioned. And so that will continue on right up to the final minutes before we lift off this morning, and the team will then close off those vent valves and bring the tanks up to flight pressures, getting ready to light the 9 Merlin engines.
We just heard the SpaceX chief engineer, Paul. They gave the go for launch at T-minus 4 minutes. That was just a few seconds ago.
Yeah, the team continues to work, Daryl. We're down there in the final minutes to making sure that propellant loading is finalized. The flight termination system is armed and ready to go. And
Stage
everything
1
gets
LOX load
ready.
is complete.
And there we just heard Stage 1 LOX load is complete. That's another milestone to get that tank to its full potential. They'll continue to top that off as they continue to load Stage 2. And once we get to a Stage 2 load complete here in about 50 seconds, Stage 1 and 2 will continue topping, and then we will shut those vent valves and bring the pressure up in the tanks, getting ready again to bring, as I said earlier, to bring those 9 Merlin engines up to speed and get ready to lift Falcon 9 and IXPE off the pad.
And there you can see the white condensation clouds from the icy cold rocket and that super chilled minus 400 something degrees. I would say the engineer knows the exact number.
The super chilled LOX is around, they super chill it down to minus 340
degrees
F.
Number. That's right. It's super cold.
It's super cold.
And it's nearly filled.
Stage 2 LOX load is complete.
That's the call we were looking for there, Daryl. Stage 2 LOX load complete. So Stage 1 and 2 now have full tanks of liquid oxygen on board and RP1, rocket propellant 1. And the team will continue to top those off and get ready for liftoff here in about 1 minute and 40 seconds.
And since we are in a nighttime launch, look towards the base of the rocket. Right around 2 seconds, you'll see a green flash. That's a mixture of hypergolic ignition with some chemicals that basically help fire the rocket up.
Yeah, we have some gas generators that start the engines up to help basically provide that ignition. You know, talking about your little science right there, it's basically a fire triangle, right? We have RP1 as a fuel, liquid oxygen as an oxidizer, and we just need to provide a spark to get the engines going, and that's what you'll see there just prior to liftoff.
T-minus 1 minute and counting.
Falcon is in startup.
And now you heard the startup, which means the computers on board Falcon 9 are now in control of terminal count.
That's correct, Daryl, and we should be hearing the final go here from the team.
LD go for XP launch.
And there we just heard launch director giving the go for the IXPE launch. So things are beginning to ramp up here, and we will see that the vent valves get closed. The team is ready to go, and IXPE will be on its way here in about 30 seconds.
T-minus 20 seconds and counting until liftoff. Okay, and here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And liftoff. Liftoff of Falcon 9 and IXPE. A new set of X-ray eyes to view the mysteries of our skies.
We hear the launch vehicles cleared off, and we're hearing nominal chamber pressures on all 9 Merlin engines.
Beautiful shot there showing the VAB and the rocket lifting off. The vehicle's pitching downrange. Onboard camera showing you right down the booster.
Power and telemetry nominal.
So we're seeing that everything is performing nominal so far on the Falcon 9, Daryl, and some beautiful liftoff this morning as you and I get to now experience that rumble from the Falcon 9 here at the Mission Director Center, Hangar AE. Things continue to perform well, and we hear that the vehicle is supersonic, and our next milestone we're looking at to get through max Q, our maximum dynamic pressure.
Falcon 9 engines pulling back just a little bit as that max Q milestone passes. Beautiful shot right there.
Vehicles made it through max Q, and that's great to hear. That's the point of maximum stress on the vehicle, Daryl, and the Falcon 9 is performing well as we see that onboard camera and the exhaust and flames from the 9 Merlin engines on board. XB continues downrange successfully and nominally so far.
Stage 1 trajectory is looking good. They're starting to chill now the second stage engine, get it ready to ignite. Everything flying on track. We are 2 minutes into flight. You see those 9 Merlin D engines all lit up. And in just about 20 seconds, those engines will cut off. And rapid succession, we'll get MECO, you can see the progress bar across the bottom of your screen. There's a shot from inside the Falcon 9 rocket.
First stage engine cutoff.
Stage separation confirmed.
And there we have main engine cutoff, and you just saw that the stage 1-2 SEP on the video as
MVAC
stage
ignition.
2 MVAC D engine gets ready for ignition, and we see that we have ignition on the MVAC D.
It's a great sign to see that engine glowing red hot as the first of 2 burns takes place. The rocket falling back to Earth, the first stage of the rocket. We hope to get a shot of it as it deploys its grid fins and prepares for its landing. That is on the left side of your screen. On the right side of your screen is the second stage. It's dark out, so of course not going to see a whole lot, but you will see that left side light up when we have that entry burn as the rocket booster falls back through Earth's atmosphere, and they slow it down a little bit.
We should hear fairing jettison here shortly, which
Fairing separation confirmed.
there we have fairing separation confirmed, and
watch this.
And we see that on the video here, and that now exposes XB to the environments of space. It was protected by that fairing on ascent for aero heating and loading, and things are going well. Flight looks nominal so far. MVAC D is performing very well. Chamber pressures look good, and continues on its course.
4 minutes into flight, everything looking nominal. 190,000 pounds of thrust from that engine right there. I call that the MVAC engine.
Acquisition of signal, Bermuda.
Four minutes and 30 seconds into flight. They have a couple of different angles off the back of the second stage.
I can say, Daryl, as we look at this and we continue to watch the data and things perform nominally, I'm just feeling real excited about how second stage is performing. I mean, we had an on-time liftoff this morning at 1 a.m. with the stage 1, and stage 1 continues to fall back to Earth. We should be seeing that entry burn in about 2 minutes to start the recovery of the first stage. But stage 2 and this MVAC-D engine is performing extremely well right now, and putting IXPE on this path, that circular orbit that we talked to get started before we have that second burn. So things continue to look good on this mission.
Trajectory.
There's the call out that everything is looking, as you said, great with stage 2. This, the 130th launch of a Falcon 9 rocket carrying the IXPE spacecraft. First launch also from Kennedy Space Center's Launch Complex 39A.
Yeah, for Launch Services Program, as we stated earlier, it's the first dedicated scientific mission for us. We are so excited to be launching from that historic pad with a Falcon 9, where astronauts have launched from during Apollo and Shuttle, and now we get to launch one of Launch Services Program's science missions.
Stage 1 FTS is safe.
From there, and everything looks great. We heard that Stage 1 FTS is safe. That's a good sign.
Stage 1 entry burn startup.
And we're seeing the startup of the Stage 1 entry burn. You can see there on your left side of your screen the 3 engines that have started up to slow that first stage down as it re-enters the atmosphere, along with the grid fins as it continues to keep the booster on track and steer.
And as that booster falls, this engine burn, roughly 30 seconds long, just basically slowing it down as it goes through the atmosphere.
Stage 1 entry burn shut down.
And the Stage 1 entry burn there is now finished. Looking now to Stage 2, this one will cut off in about 60 seconds. That will complete...
Stage 2 on nominal trajectory.
And that will complete the first burn. Look across the bottom of your screen. You can see engine cutoff 1. That's our next milestone. Look to the clock in the upper left-hand corner. 40 seconds from now, we'll have that next milestone.
We hear from the team.
Stage 2 FTS is safe.
We hear from the team. Continue to look at the data, Daryl.
Stage 1 transonic
is still nominal and looking good. Stage 2 is performing very well, and chamber pressures remain within family and nominal for this flight.
And just seconds away now from the cutoff of that second stage engine that you're watching there, burning brightly, carrying IXPE through space into its correct orbit.
Stage 1 landing burn.
And back engine cutoff.
So there we can see that the Stage 1 landing burn has started to get the first stage landing on Just Read the Instructions. And we also heard the call out that SECO 1 has happened. Second stage engine shut off. Landing legs have deployed, and we can see the first stage coming down on the drone ship there.
A little pixelated, but that is the image from the drone ship. Live pictures coming from SpaceX's Just Read the Instruction, and there you see it. Looks like the rocket made a great touchdown.
Absolutely. We just heard from the team that they're confirming that Stage 1 is down safely, and that's exciting to be able to bring that booster back for a 5th time. We'll look forward to see where that booster 1061 shows up for its next mission. It did well on the first stage burn, getting second stage on its way. Second stage picked up, as we said, nominal trajectory and continued to burn. We are now in a coast phase, Daryl, that you had mentioned earlier, as we head towards that western coast of Africa to get ready for second stage engine burn number 2.
And there you see the ground track that we've completed so far. And as you mentioned, all along the path today, everything looking great, from launch to separation, the booster coming back down, and now in that coast phase. You can see there the engine bell is now back to ice cold, so it's not firing. And that right there is IXPE, the camera pointed. You can see its 3 telescopes through those 3 curves in the front. IXPE is in space, and we are tracking it as it coasts. And as it does so, we're going to tell you a little bit more about the science, and for that, let's throw it back to Megan and Marie.
All right, thank you, Daryl and Mick. If you're just joining us, you are watching NASA's official live launch coverage of IXPE, NASA's new X-ray observatory. It launched about 10 minutes ago. right behind us. We had a beautiful view here, Megan.
Yeah, wow.
Just spectacular. Aboard a Falcon 9 rocket right at the top of the window.
Yeah, beautiful views. Honestly, it was the sound. I was like, whoa, it really made like our whole host desk here shake. It was really, really cool to see it from out here. Now, IXPE will spend the next 2 years visiting at least 40 celestial objects in our universe, like black holes and exploded stars, to unlock some of the secrets of our universe. And let's bring back NASA's Jasmine Hopkins now. She got to watch the launch with the Associate Administrator for NASA's Science Mission Directorate. Jasmine.
Thanks so much, Megan. What a beautiful launch. And now I am joined by Dr. Thomas Zurbuchen. What did you think of that?
Oh, it never gets old. I loved it.
Right. It really does never get old. We love seeing it over and over again. So now that IXPE is soaring high above us, let's talk science. What are we hoping to learn from this astrophysics mission?
You know, it's really rare that we can build a mission in which we look at the universe in an entirely new way. And by doing that, we're going to learn about the most amazing objects of the universe, like black holes, these pulsars and exploding stars, really high energetic, violent parts of the universe we're going to learn about in a way we've never had before.
Right, when we're really excited about this new perspective. IXPE was chosen back in 2017 as a small explorer mission, but by what you're saying, I mean, there's nothing small about the science we're doing here. So what does that classification, small explorer, mean?
We have multiple missions at different sizes. Of course, we have large strategic scale missions, and the small explorers are around $150 million. So it really talks about the cost of the mission overall, and that's what a small explorer is about. Very successful missions. Some of the most amazing missions, frankly, that we know about are small explorers initially.
Right. We're really looking forward to the success of IXPE, and this has been a big year for the Science Mission Directorate, you know, with Earth science and asteroid research, and James Webb is right around the corner. So what do you think about that?
Well, I think we have a two-course dinner here. That's the appetizer, and the main dish is coming in 2 weeks. We're going to launch the Webb Space Telescope. It has been 20 years in the making, and we couldn't be more excited. You know, a ginormous telescope, much bigger. The area, once it's deployed, the area of tennis court in size, 6.5 meters of mirror, right? It's an incredible telescope, a strategic scale mission.
Right. Yeah, absolutely. Very excited for James Webb coming right up. And can you tell me what sets IXPE apart from other astrophysics missions that we've done?
Well, it's unique perspective. It's very targeted towards X-ray, the X-ray sky, and very targeted with that new methodology to look at the sky in a new way. So IXPE is different from that perspective. But it will, you know, when you look at any object in the sky, look at black holes. We know that black holes are the center of galaxies. So often we look at, you know, the images of the Hubble Space Telescope of some of these galaxies. So if you really want to understand a given object, you need to look in many different ways. IXPE will be very complementary, very important view to add to the other views.
Exactly. So IXPE is encouraging us to keep looking up. Thank you so much for being here, Dr. Zurbuchen. And now we're going to get back to Megan and Marie.
All right, thank you so much, Jasmine. Joining us now, we have the privilege of having Dr. Sarah Lipsey with Ball Aerospace. You're the Deputy Director for Civil Space for New Business. Excuse me, that was a bit of a tongue twister for me. Thanks for being here, and congratulations to you.
Thank you so much. We are so proud at Ball Aerospace of the launch that just occurred that you all watched. Years in the making. And my goodness, that feeling you ladies were just talking about, when it hits you, it hits you. That was really fun. So thank you.
Yeah, it's really great to see, you know, that you partnered with NASA and the Italian Space Agency to make IXPE come to life. How does it feel seeing it now on its way, embarking on its 2-year mission?
So excited, right? The science from this mission is just going to change textbooks. It's going to be groundbreaking. And we are so proud of our partnerships with NASA, with the Marshall Space Flight Center, of course with the Italian partners. We could not have done this without them. And even smaller partners, various hardware partners, our partners at the University of Colorado, who will bring the data to the ground and process it for us too.
And Sarah, we have some video that you shared with us of Ball Aerospace when you were still in the testing phase, and of the boom in particular. That's really impressive when we see it stretch all the way up. There's some video of it there. Can you kind of talk us through what we're looking at here?
Yeah, sure. So to fit in the size casing that this needs to go in, we had to squish up this 4-meter, about 12 feet boom. And so it gets twisted down in, and when you push the button, the jack-in-the-box pops right open. It turns around 3 times as it extends. And so this will happen on orbit in about 7 days. Somebody down here will push a button and pop it goes, and extend those telescopes out. You can see the 3 identical round telescopes there going up into our clean room there in Boulder, Colorado.
And Sarah, the boom is important, right? Because the mirrors and the detectors have to be a certain amount of feet away.
That's exactly right. Yeah, it's really important to have the alignment very precise and to have that separation between the detectors and the telescope so that you get just the right collection of these X-rays that we're looking for.
So now that IXPE is safely on its way, it's still got a little ways to go before spacecraft separation, but what's next for Ball Aerospace?
Oh, we're working on NASA's next missions too. Lots of work to do. We work in all of NASA's areas. So X-ray astronomy is just one of the fields. We're working on other astronomy missions, earth science, heliophysics, planetary science. We've got everything covered. We'll be watching, of course, for IXPE over the next month as the mission gets commissioned and then starts to turn on to CAS-A, our first science target.
All right,
Very
Dr.
cool.
Sarah Lipsey, thank you so much for joining us.
Thank
Congratulations once again.
Thanks, ladies.
We want to send it over to Jasmine Hopkins now. She is with the principal investigator from our Italian partner. Jasmine?
Thank you so much. Yes, now I'm joined by Paolo Sofita. The Italian Space Agency provided the detectors that are on IXPE, and Paolo is joining us from the Italian National Institute for Astrophysics. Thank you so much for being here.
Thank you for inviting me.
Absolutely. What did you think of launch?
It was great, fantastic, really, really exciting.
Right. Very beautiful. Can you tell me, how did you and your team develop IXPE's polarization detectors?
Actually, I started to work on X-ray polarimetry back in the late 80s with Enrico Costa, and we at the first worked on the so-called classical techniques to measure polarization. And then we actually understood immediately that we have to change technique to arrive to the sensitivity needed for astrophysical sources. So we went to visit Ronaldo Bellazzini in Pisa, and that was of the INFM, and that was the key of the success. Yeah, we imaged the detector in order to do this measurement. And Ronaldo made these little things here that is actually an ASIC CMOS chip that makes the image of the photoelectron track and allows to measure polarization. We also built all the facility that allowed to calibrate the detector and to know what is the real response of the detector that has been built.
Right. So you have, a pretty long experience with this. You mentioned you working on it back in the 80s. So what are you looking forward to learning the most from IXPE?
Well, the IXPE will open a new window on X-rays. We will measure polarization from almost all the classes of celestial sources that emit X-rays. But basically, one measurement that can be very exciting is the mystery in the center of our galaxy. We have in the vicinity of our galaxies molecular clouds that are cold, but they are shining X-rays. And there are no bright sources nearby to understand why they are emitting X-rays. So the model here was done back in the 90s by Rashid Sunayev, that said that what we are looking from the molecular clouds is the radiation reflected by them that was emitted in the past by our center of galaxy, that is a supermassive black hole. Now the supermassive black hole is very dim, like our sun placed at the center of the galaxy. But a few hundred years ago, it might be 1 million times larger.
Right.
The maximum flux of 1 million times larger. So basically, we can measure polarization from these molecular clouds and set the time when our center of galaxy was an AGN.
Right. So thank you so much, Paolo. Really appreciate you being here. And now we're going to get back to Marie.
All right, thank you so much, Jasmine. Now, some of the more mysterious subjects IXPE will study are magnetars, neutron stars the size of a city with the strongest known magnetic fields.
Yeah, isn't that crazy? An event last year involving one such magnetar stunned astronomers. Take a look.
A high-energy outburst seen in April 2020 confirmed the surprising range of supermagnetized objects called magnetars. This blast of X-rays and gamma rays triggered instruments on several spacecraft. The eruption was over in the blink of an eye and originated from a galaxy about 11 million light-years away. Magnetars are part of the family of compact objects known as neutron stars, the crushed leftover cores of exploded stars. What makes magnetars special are their incredibly strong magnetic fields, up to 1,000 times stronger than a typical neutron star's. Sudden changes to this ultra-strong field are thought to drive brief, enormously powerful outbursts called giant flares. One giant flare in our own galaxy affected Earth's upper atmosphere from 28,000 light-years away. On April 15th, detectors on NASA's Fermi, Swift, Mars Odyssey, and WIND missions, as well as on the European Space Agency's Integral satellite, picked up a rapid surge of X-rays and gamma rays. Using the arrival times of the signal at different spacecraft, astronomers pinned the burst to NGC 253,